All right, Teach, how you doing? This is Project D2. Question one, what is an op-amp? An operational amplifier, or op-amp, is an integrated circuit IC that amplifies the difference between two input voltages. It functions by using this voltage difference in an internal high gain to drive the output to a voltage that reflects the amplified difference using utilized external feedback components like resistors to precisely control the gain and behavior of the circuit. Now, question two, the circuit, explaining the circuit that I designed for D1. Um, this circuit represents an active low-pass filter, specifically a first-order active low-pass filter using an operational amplifier, or op-amp, in the input signal being a 40 hertz AC source is connected to an inverting input of the op-amp through a 1,000 ohm resistor, 1, and a 10 let me get that word correct, and a 10 microfarad capacitor. These components, which is this one here, these components, along with the 3,000 ohm resistor being here, feedback resistor of the 10 microfarad capacitor in the feedback loop, determine the filter's characteristics. Okay, now the non-inverting input of the op-amp is connected to ground, being here. All right, which serves as the common reference point for the circuit. The op-amp, the output of the circuit is taken from the op-amp's output terminal, providing the filter signal. Output, correction. This is your output, this is your input. So here's that loop that you were looking for. All right, the circuit functions as an alternating frequency above a certain cutoff frequency, allowing lower frequencies to pass through with minimal attention. Attention. I can't get the word properly in my head, forgive me. The capacitor in series with the input resistor and the capacitor in the feedback loop, going like so. All right. What was that? Create frequency dependent independence. Correction. Frequency dependent impedance at low frequencies. The capacitor acts as open circuits, allowing the signal to pass. As the frequency increases, the impedance of the capacitor decreases, effectively shutting higher frequencies to ground to reducing the feedback impedance, leading to attenuation. I cannot get that word. This type of circuit is commonly used in audio systems to remove high frequency noise, in control systems to smooth out signals, or in sensor applications to filter out unwanted high frequency interference. All right. Okay, Teach. This is the second circuit. Let's see. What was the question on this one? Okay. This circuit appears to be a wave folder. I mean, that's what I was working on, trying to figure something, or a single processing circuit. Designed to introduce harmonic content by distorting the input waveform based on the operational amplifiers and diode arrangements. Okay, now, okay. All right. Once again, this circuit is a type of op-amp based oscillator. Likely, once again, likely a RC phase shift oscillator designed to generate a continuous oscillating output. In this case, a 40 hertz signal as indicated. Let's see if I can zoom this up some. Here we go. All right, a 40 hertz signal as indicated. All right. Overall purpose. The primary purpose of this circuit is to guarantee a stable, continuous sinusoidal or near, I cannot pronunciate that word properly. Okay. Waveform at a specific frequency, being 40 hertz. Okay. Now the components and the functions and the interactions between these components. The op amp, you got two of them on here this time. Okay. The triangles represent operational amplifiers, which provide the necessary amplification and phase shift for sustained oscillations. One op amp likely acts as an amplifier, while the other might work as the feedback network or a buffer stage. Resistors in this, we have a couple of them, 1, 2, 3, 4, 5, 6, and 7 in total. Okay, the resistors, particularly those in conjunction with capacitors, if present, would be though not explicitly labeled as such. The 40 hertz source implies a frequency-dependent network from the frequency-determining network and potentially provide feedback and biasing. The 5-volt supply being up here, okay, this provides the necessary power to the operation amplifiers, enabling them to function. Going 1, 2, and they're both tied in, as you can see. All right. The 40 hertz source, this label likely indicates intended or designed output frequency of the circuit.
You're on almost on 10 minutes.
It's fine. We'll send this one on to the other. Well, I'll have to figure out how to get them to send it through YouTube. Let's see what else. And then we have, what else do we have? 40 hertz. Okay, so here 40 hertz. This likely indicates the intended design output frequency of the oscillator, or it could represent an input signal being processed by the circuit. If it's not a self-oscillating design, but rather a filter or amplifier for a 40 hertz signal. Assuming it's an oscillator, this is the target frequency. Ground symbols representing the common reference point for the circuit's voltage. Now, effects of changing values, increasing the resistor's resistance, the oscillator increasing the resistance of the resistor within the frequency determining network, would typically decrease the oscillation frequency, as it would increase the time consistent of the time constant of the RC network. Increasing capacitor value, similarly, increasing the capacitance of the capacitor in the frequency determining network would also decrease the oscillation frequency. Let's see, what else? Changing value changing voltage supply, alternating the positive 5-volt supply voltage would primarily affect the amplitude of the output signal and operating point of the op amps, but generally not the oscillation frequency itself, unless the change is so drastic it affects the op amp's ability to operate linearly or causes saturation, which is one thing we don't want. Let's see. Changing the signal. Once again, if the 40 hertz source is an output signal rather than an indicator of the output frequency, changing its characteristics, frequency, or the amplitude would directly impact the output of the circuit, as it would be processing that input. And I believe we have marked this is a 40 hertz, 1, 2, 3, 4, 5, 6, 7 resistors. This is your MOSFET, ground, and your OPs, op amps. Okay, output, input, and of course everything else is wire. That's what all of that power juice is running through. All right, hopefully I answered all of the questions correctly and I gathered all of the information properly for you. If there's any questions, please let me know, and you have a great day.